Let's have a look today at using maximums and minimums to actually solve some basic problems. So for a rectangle of area 50 meters square, express the perimeter in terms of the length. Alrighty, so area for a rectangle is determined by length times width. And we know that the area is 50. So 50 is equal to length times width. But we would like to express the perimeter in terms of the length. So that means what we want is the length, the L variable, to stay on the right hand side. So let's rearrange this so that it looks like so. Alright, so now we've determined the width in terms of the length, which means we can now express the perimeter. Or perimeter of a rectangle, you can write it in a few different ways, is 2 times the length plus the width. Alrighty. Well, we know what the length is, it's just L, and the width is 50 over L. So let's substitute that in. And we can expand the brackets and we get 2L plus 100 over L. And that is our final answer. The perimeter can be expressed in terms of the length as 2L plus 100. Alrighty, so let's actually now that we've got an equation like that, let's see if we can actually do something with it. Novak has 80 meters of wire fence to fence 3 sides of a rectangular backyard. The 4th side is existing fence completing the rectangular backyard. Use calculus to determine the maximum area of the backyard and state its dimensions. Alrighty, so let's just draw a quick picture so we understand what's going on. We've got a fence and we're going to be building off that fence a rectangle in which the sum of these sides is going to add up to 80. So let's give some names to things. If we call this side over here X and this side over here Y, well, we can comfortably say that 2X plus Y must be equal to 80. Alrighty. And since we know that, now we can write y, the long side, in terms of the x. So 80 minus 2x. Alrighty. So this is now going to be really useful because now we can determine the area of this rectangle. The area of the rectangle is just x times y, but we know that y is really equal to 80 minus 2x. And at this point, we can now expand the brackets. 80x minus 2x squared. And now we can start using calculus. So this is our function, and we are looking to maximize this problem. Alrighty, so first of all, let's work out dA dx. Alrighty, so there's our maximum function. And let's looking for max also means that we are looking for when dA dx is equal to 0. Rearrange this equation. So that means that x equals 20 is a stationary point. Now, just to make sure that this is in fact a maximum, we should check the 2 points either side of it just to double check. Alrighty, so we know that the shape and the gradient at x equals 20, let's work it out at x equals 19 and x equals 21 around it. Alrighty, and so we can, using these two, we can see that we've got a positive slope, a 0 slope, and then a negative slope, which is in fact a maximum. Therefore, x equals 20 is a local maximum. Now, the only question we have to think about is it then a global maximum? Now, fortunately, we don't have to do much work. We just have to think about what are the extremities of the overall equation that we had. Factorizing this may actually help us here. Alrighty, so let's have a look at this equation here and have a think about what these mean. Well, x could be equal to 0. What would happen if x was equal to 0 here? Well, the area would be equal to 0. Well, that's no good. So what's the other extremity? Well, the other extremity hides in here. What happens if x is equal to 40? Well, 40 minus x will also give us 0. So that's no good either. In fact, this is a parabola, which makes a lot of sense being that we have the polynomial order 2, but it's got two roots, one at 0 and one at 40. And it is a parabolic shape, which means that that maximum we found earlier is certainly going to be the maximum of the function. Now, the only thing we've got to now think about is that what is the y-coordinate of the area? That's really easy to simple. We just need to substitute it in. So the area of this function when x is equal to 20. Alrighty, and you can see there that the maximum area is 800 square meters. Alrighty, so therefore, the maximum area is equal to 800 square meters with dimensions of 20 by something. So to work out the something, well, that was my y that I worked out right at the beginning, so 80 minus 2x. So substitute in x equals 20. And we get the width is 40. And there is our final answer. So it's a 20 meter by 40 meter rectangle. Alrighty, thanks for watching. I'll see you on the next one.